Hi everyone, so today we're going to be going over a key new concept regarding trigonometry called the reciprocal functions. So we know that we've learned about sine, cosine, and tangent. They have three additional reciprocal functions for each one of those. So for example, sine of an angle, sine of an angle, so I'll say sine of x. Is equal to the opposite over the hypotenuse. Sine's reciprocal function is called cosecant. It's simplified, we write it CSC. Okay? So cosecant, if it's a reciprocal function, means to flip. So it would be the hypotenuse over the opposite. All right. Then we've got cosine. Cosine of x is equal to the adjacent over the hypotenuse, adjacent leg over the hypotenuse. Its reciprocal function is called secant. We simplify that to SEC, sec. And that would then be the hypotenuse over the adjacent. The last one would be cotangent. Sorry, the last one would be tangent. Sorry, I jumped ahead. And we know that tangent is opposite over adjacent. We get those from SOHCAHTOA. So its reciprocal is called cotangent. And we simplify that as cotangent x. So adjacent over opposite. Now, it's pretty easy. You're just reciprocating it, but these are new names that we kind of have to bring into our, into our toolbox, okay? So here's what we'd be doing if we were solving a triangle. I give you a triangle. I have a side length 7, 24. I need to find the hypotenuse. So I either use the Pythagorean theorem or, that's right, you said it, I use the Pythagorean triple, which this is 7, 24, 25. So my hypotenuse is 25. So now, given the triangle, I can solve for the ratios. So sine of b, so I'm looking at b, I would want its opposite over the hypotenuse, so 7 over 25. So cosecant of b would be 25 over 7. All right, cosine b would be adjacent over hypotenuse, so 24 over 25. So secant b would be 25 over 24. Simple as that. Again, it is something that you, though, have to remember. And you have to remember that cosecant goes with sine and secant goes with cosine, which is like counterintuitive, right? All right, tangent, opposite over adjacent, would be 7 over 24. So the cotangent ratio would be 24 over 7. Okay. Now, I want to look back at a few relationships. So yesterday, or in the previous lesson, we talked about sine, cosine, and tangent's value at these special angles. So we're going to do this again. So we're going to look at sine, cosine, and tangent at the special angles from the special right triangles. Okay? So quick review. We have a 30-degree angle, which is a special angle, a 45-degree angle, which we call a special angle, and a 60-degree angle, which is a special angle. So we recognize that the sine of 30 was 1/2. We recognize that the sine of 45, its ratio was root 2 over 2. And the sine of 60 was root 3 over 2. Okay, if you don't recall those, go back to the previous page in the notes. Look at how we got them. These are the ones I said we're gonna need to know. Okay, we're gonna have to know the sine of 30 is 1/2. Sine of 30 is 1/2. Okay, cosine of 30 worked out to be root 3 over 2. Cosine of 45, root 2 over 2, root 2 over 2, and then cosine of 60, 1/2. All right, and then the tangent was the sine over the cosine, because that is one way to see tangent, sine over cosine. Or use the ratio, and we got that tan of 30 was root 3 over 3, tan of 45 was 1, and tan of 60 was root 3. Okay, so I want to use those right now. We're going to use those relationships to see if we can find the following. It says find each of the following. Sine 30 squared plus cosine 30 squared. Okay, so sine of 30 is 1/2. So I'm going to Substitute that in. Cosine of 30 is root 3 over 2. I'm going to substitute that in. Okay, now I'm going to square them. So 1/2 squared would give me 1/4. Root 3 over 2 squared would give me 3 over 4. Add them together, so 4 over 4, and I get the number 1. That's interesting. Okay, sine of 45 and cosine of 45. Okay, so root 2 over 2 squared plus root 2 over 2 squared equals 2 over 4 plus 2 over 4, which is 4 over 4, which is 1. Huh. So let's try the last one. Sine 60, you do it. And pause it and come back. Okay, so hopefully you plugged in sine of 60, root 3 over 2, squared plus 1/2 squared equals 3/4 plus 1/4, which equaled 1. So we investigated this in class, but if you weren't there, this is basically what's happening. And what I'm wanting you to recognize is that they all equal 1. Well, that's a true statement, and we call that the fundamental identity. When you take the sine of an angle and you square it, and you add it to the cosine of that same angle and you square it, you're always going to get 1. All right, now the unfortunate thing is that we don't actually write this as sine 30 squared. In trig, we would write it, like if I had sine x, I wouldn't write it as sine x squared. I would write it as sine squared x. So we're going to have to get used to this weird looking notation now, okay? So the fundamental identity is really sine squared x plus cosine squared x equals 1. And that will work for any angle on the unit circle. So as long as the angles are the same, if you square them both, their ratios, you're going to get the answer of 1. We call it the fundamental Pythagorean identity. The fundamental Pythagorean identity. And I guess if we're really thinking about it, anything that's fundamental, we should make sure we have in our toolbox, okay, in that brain. All right, guys, hopefully that was helpful. Have a great day.